Welcome. In this video, we're going to take a look at encapsulation, which is one of the four pillars of OO object-oriented programming. So what I'm going to need you to do now is to open Visual Studio and open your previous project. Once you've opened your project that you did last video, then I want you to create a brand fresh new Python file. And I want you to copy and paste. Now from here, I need you to save this. And I'm going to save it in a folder this time because what I'm about to show you requires to have two Python files in the same folder. So I've created a folder called Python on my desktop. And I'm just going to call this one OOEncapsulation. And I'll save that. All right, so the first thing that we're going to be doing is we're going to be creating a different way to drive our class. Now, in the previous example, we put our driver program in the same file as our class, but what we can do is actually create a separate Python file. So I'm just going to go New File, and I'm going to call this one driver. So I'm just going to save this in the same directory as my Python program. Okay, so notice here how we've got OOEncapsulation.py and we've got driver.py now. So they're in the same directory. What we're going to do now is I'm going to basically transfer this driver code into this driver. And so the way you do it is we're going to need to import our class from that file. So what you do is you say, well, from the file name. So we've called this one OOEncapsulation. So we say from that file, I want to import the class. Now in this case, it's the human class. And then once I've done that, I should be able to do my instantiation as normal, and it actually works. I'll just copy all of this, and I'll just run this. And you can see here that it's working. So I've now removed it, and I'm just going to make that correction from that mistake that was made in the last video. That should be self.age. Now, the next part is all about creating methods instead of updating attributes directly. The problem with what we did in the last video tutorial is that we were directly accessing the attributes of that object, which breaks the rules of encapsulation. In other programming languages, we have protection mechanisms to protect us from doing such a thing. And we call them private attributes, or protected attributes is another example. Currently, the way we are working it is that we have public attributes. Now, without getting into too much detail, and you'll hear me as we unpack these concepts, talk about how Python dealing with this, is that it just doesn't deal with private attributes like Java or C# would. There are conventions that we're going to follow, but it doesn't necessarily stop anyone from doing what we've just done. In Python, a public attribute is simply just self dot the attribute name, so self.name. A private attribute in Python is denoted by two underscores. All right. Now the problem is if I actually run this program, I'm not going to get some sort of error when I run it. Because hypothetically what should happen is because it's a private attribute, I shouldn't be able to make any changes. But if you see here and I go human1.print all attributes, run that, you'll see that it's still going to print bias's name. So Python really is only just more telling you that this is, as a programmer, you shouldn't be directly changing these attributes directly. You should be using a different way. But there is actually no protection mechanism per se. We could talk about name mangling in a later video, perhaps maybe later in this one. But really, there's nothing stopping you from doing it. But having said that, what we can do is still use these conventions to say, hey, we still want to tell other programmers and follow this convention that they should not be directly accessing these particular attributes. These are private. So what do you do if you can still directly access? What you should do is create getter and setter methods. Before we do that, let's just modify this so that we'll create a special method that instead of us directly updating it like this, it's done within the object itself. So at least there's some sort of encapsulation in there. So in here, I'm just going to create a new method called update all attributes. And you can see here, what I can now do is I can create some sort of program that says, all right, well, I want you to update the name, update the details of this object. All right. So, you know, we could say self._name is equal to whatever someone inputs. All right. We could say then self.height equals you know, the height that we enter in. I'll just go and fill these out now. Okay, so here what I've done is I've created my own little method that will allow the person to update all the attributes. So what we should do is save this particular file and go into our driver. And instead of doing this one by line, what we can do is simply run, if I just go human1 dot update all attributes and run this. So now it says, all right, update the details of this object. So it's Tobias, John, Paul, Jakes. And we see here that we get an error. And you will note this because you will see it and it's saying, hey, the human object in the print all attributes has an attribute name. And you can see here that we initially used public attributes. But now that we've changed it, we need to also tell this, say, hey, everything's changed now. So it's going to be double underscores. So I'm just going to save this. I'm going to go back to my program now, and I'm going to do this again. And now that works. Okay, you can see that I've now populated all that information for the particular object. Now, I guess the advantages of this particular way of doing things is there's two real big advantages. The first one is it abstracts away the logic from the person programming. So someone that's created this class knows intimately how this all works. But really, if I'm just creating a new object, for example, let's say I'm in some sort of Sims kind of style game and I need to create a new person, I don't really need to want to code all the attributes and stuff. I'm happy just to reference the object and say update all attributes, and it does it kind of for me. Print all attributes and it does it all for me. So that's the advantage, is that it abstracts. The second advantage is that it becomes easier to maintain. So if you've got lots of parts of this program referencing the update all attributes, rather than having copies of it everywhere or even a function call for different objects, for example, each object has its own function call, we now know that's in a class. It's in the one spot only, and all the changes need to be made are in here, and it's for everyone. If I need to say, you know what, I forgot to say, you know, put the height in centimeters and the weight in kgs, for example, that has absolutely no effect on this. I don't need to change this code at all, because when I save this, the reference to it then changes it. So if I have a quick look, I'll just go down here, and you see now it's all changed. So you can see there are huge advantages. How we deal with private attributes in object-oriented programming is the idea of getter and setter methods. So ideally, you should never be directly changing the object's attributes. However, it's okay to request changes from the object's attributes. And the way to do that is using a public method or a public interface to do so. So let me give you a quick example. Let's say I wanted to be able to change the name. Actually, that's probably not a great example. Let's say I wanted to change the weight. All right. What I can do is I can go to create my own thing called set weight. Actually, I'll go get weight to start with. Now, ideally, what I would want to do here is I don't particularly want even to be able to print the weight directly either. Like, so what I shouldn't be able to do is this. I shouldn't be able to directly access it. So what I can do is create my own little method called getWeight, which does the printing for me. So self.weight. All right. And then if I wanted to run that, I would just go human1 dot get weight. All right. Likewise, if I needed to change the weight, I would create a setter method. So in OO, it's very common to have a getter method and a setter method. And what you can do here is you can go, well, I want to set my weight, which will be self. And then what we're going to be doing is we're going to be giving a value that the weight needs to be set. And then what we can do here is we can say, well, self.weight is equal to the value that we've been given. And so if I wanted to actually use this, I could say, well, human1, let me just save this, human1 dot set weight, and I'm going to say, well, their weight now is now 6. All right. And so what happens is when that gets run, it gets sent down to this particular value here, and then it updates the weight attribute. And you'll notice if you do it this way that you are never directly changing the object's attribute. You are going through the object itself firstly, who is then changing their own attributes, which they're allowed to do. You might ask, that's a lot of extra work. I've basically had to do now 4 more lines for each attribute. And the answer is yes, it is more work. But the thinking behind it is that if you can self-contain everything inside the object, down the road, you're going to have less issues when you try and update or do some sort of changes to your program. So I guess what they're saying, I guess what people that support the OO principles is that down the track, it's going to save time by doing it this way. It certainly doesn't reduce the amount of code, but what it does is it reduces the amount of issues down the line. Let's now quickly run this. For these purposes, I'm just going to enter some different input now. And you can see here that it's now pulled, this get weight method has pulled the weight, which was 65, and it did actually set the human one's weight. However, I don't believe we didn't print it after, so we didn't get the weight again. So, but you can imagine it would have overridden the weight. Instead of 65, it would have been 6. The next thing that I want to talk to you about, which kind of links in with what we're discussing, is sometimes rather than populating all the attributes in a separate method up here, we want to be able to populate the attributes at instantiation. So rather than using the update all attributes, we can simply use what we call a constructor to allow the person at the time of creating the object to populate all these values. So what we want to do is actually move all of these default values as parameters. So here, instead of saying, well, I'm going to say, well, name by default is nothing, height by default is 0, weight by default is 0, age is 0, gender is nothing, and date of birth is nothing. Now, rather than leaving these here, what we can then do is associate these with the parameters. So for my first parameter is name. So I can say whatever the person enters in, it's then going to store it into the attribute self.name. Likewise, if I do that for height and for weight and for age and for gender and date of birth. Now, what you want to see is probably how does this relate in our main line or our driver? Well, let's just get rid of this for the moment. Now, if I go back and I say human1 equals a new human, you'll see up the top here that IntelliSense has said, actually, now, rather than just putting nothing in, there are values that we're expecting someone to put in. Here is where I can now put Tobias's name. And you can see with IntelliSense that I can highlight the name there. For example, it's at the moment it's blue. It's saying the first parameter that I'm expecting to see is the name. I put a comma in. The next, put it over here, the comma. The next thing that I'm expecting to see is the height. All right. The next thing that I'm expecting to see is the weight. Next thing I'm expecting to see is the age. The next thing I'm expecting to see is a gender. And finally, the last thing that I'm expecting to see is the date of birth. So if I went to print this out now, it's all there. What if I wanted to create a second human, but I just wasn't sure, let's say there's complications at the birth, wasn't sure exactly what their name is, don't know, haven't got their details yet. No problem. I can just go human2 equals a new human, and I'll print all their attributes. Whoops, sorry. Make sure that's human2 instead of human1. And you can see here that in the first instance, it's printed all of Tobias's information. But the second one, it didn't really print anything. In fact, what it printed was all the default values that we'd set up. So in Python, what we can do is we can have almost like a blank constructor, if you like, or a default value constructor. Or we can have whatever the person puts in. So if they decide to put in all the values, it's going to override the defaults and put in whatever they've put in. If they've decided to put maybe half of the parameters in, then it's going to override half of those parameters and keep the defaults for the rest. And so that is probably the way we want to move forward, is we want to be able to have constructors that allow us to populate the attributes at instantiation. Now moving on, we can create, take this idea of public versus private into our methods as well. So we may not want someone to access a method, all right, or an object or a class, another class to access this particular method. So again, in Python, we don't have the private or the protected keyword. We have the double underscore to indicate that it's private. So let's hypothetically say that in our human, we're going to have a method called laugh. And then we're also going to have a method called tickle. Now, if my logic serves correctly, you can't force someone to laugh, right? Laughing is done by themselves, but you can do things to make them laugh. So in this baby, for example, we can tickle, which might then activate the laugh ability. So if I double underscore here to indicate that my method called laugh is private, it's going to now say increase happiness by 2, okay? The human gets happier. Now that means I'm going to need to now add an attribute called self.happiness. All right, and I'll just make that. Here I'm going to update my constructor and just say the default value of happiness is 0. A few other things that I'm going to need to update. I'm going to need to update my update all attributes as well. And then finally, I'm going to need to update my print as well, just so that it prints out. All right, I think that's pretty good. At the moment, I technically can't run this outside of my class. All right, I shouldn't be able to. So what we might do instead is create our public class called tickle. And then every time tickle is run, let's run the private method laugh. If I was to now run this and go, well, human1.tickle, and then print all the attributes out again, what I'm expecting to see is happiness go from 0, and I'm happy just to leave that as the default value, just to be 0. We're expecting to see happiness go from 0 to 2. And you can see here that initially, when we printed the attributes, happiness was 0. But then as soon as we initiated the tickle method, which is public, it then ran a private method called laugh, which then changed the happiness by +2. Therefore, once we printed it again, we saw happiness increase by 2. Now we could do this for the opposite side of things. We could have a cry method, which makes the baby cry, and we could do a public thing that anyone can do, frighten the baby, and then that would inadvertently make the baby cry and decrease happiness. So, you could play around with that if you wanted to. So to recap, what we've learned here is that firstly, in this lesson, you can create a separate mainline or a separate driver program from the actual class that you're creating. You just need to import it. The second thing that we learnt was it's important to use public versus private. It's important to use private attributes and not directly change if you're outside the class. So what we did is we used the update all attributes method, which was a public interfacing method, which is fine. But once it got into the object and ran this, then the object itself changed all of its information. We talked about the advantages of that. The two advantages were obviously abstracting the logic away from the user, and secondly, the ease of maintenance. We then talked about getter and setter methods, and the idea that getter and setter methods are kind of the way moving forward to change. If you want to be able to change the attributes, that's how you do it. So you have a public method that then changes it privately. We then talked about constructors and changing the default constructor values so that it's easier at instantiation just to populate all the information. And then we finished off by looking at private methods as an option too, which we use the tickle and the laugh as an example. I'll look forward to seeing you in the next video. We're going to be talking about inheritance in the next video.